Okay, so on the script right now, we have it where we build the UI, and if we click create skeleton, it creates a set of joints, and the joints have the names so that we can reposition them if we needed to. So let's say the character had the hand much lower or something like that. We can create the rig, and it creates the rig based off of what we have set up here. And that is where we are at with this character right now and setting up the rig. So let's take a look. Right here is where we are parenting everything. And basically at this point, let's look at, because, oops, let me run this script again. When we have the create skeleton, you can look at the joints and you can see that they are lined up with the world. They are not lining up with the orientation that we want them to have. Oops. So when they're parented here, we can see that the skeleton, the joints themselves, we can tell more on this, are not lining up with the orientation with the joint as we would expect them to be. So if we were to do this by hand, usually what we end up doing is selecting a joint like this and then going to the rigging menu set, skeleton, orient joints, and then we can tell it what axis. So the primary axis by default is X, and then we can apply. So now when we look at something like the elbow, we have to do the whole hierarchy. So let's go in skeleton, joint orientation. It is not giving us the option here, so what we can do, if we select this, right click, we can select hierarchy. That selects everything in the hierarchy, all the joints. Now let's go into Orient Joint, and then if we select this, that is not lining up. Maybe it is our orientation. So right here, the move orientation is set up to the world. If we change this to object, you'll see that it lines up now. So that gives us everything kind of lining up the way we would anticipate it. The only ones that work a little bit different are end joints. They end up lining up towards the world. Here in the spine, you'll see that sometimes it may flip in a weird direction here, so you can see that the Z is going that way, then the Z is going that way, so it's kind of flipping there. And that is something that we can look at with the script, the way we orient everything, because with the spine you'll see that as we rotate, we need them to rotate in the same direction, or else we get a kink. Kind of like what we're getting there a little bit, where it doesn't quite rotate in a smooth rotation the way we would expect it to. Okay. So let us delete this really quick. And then run this one more time just so that we can get the first part, the skeleton. So what we can do to actually get the orientation to work pretty good for us is to take one joint here and then take the next joint up the chain and do a aim constraint. So if we take the target, then object to be constrained, which would be the second object, do constrain, and we can do aim. We want to make sure the aim vector is x, the up vector can be y, that's fine. And then we can apply it, and you can see what that does is line up the x-axis along the channel that we want it to go along to go to the next joint. So we can use the orient joint the way or the aim constraint the way we did there, and then that will set up the orientation on all the joints. Where we will have an issue is with the joints towards the fingertips, because there's nothing at the end to aim towards. So what we can do with the script is actually aim towards this joint here, but in the negative direction for the x, and then that will follow through in the expected line that we are looking for. So we can say this is the target, this is the object to be constrained, then go to constraint, aim constraint, and we would do is change this to a -1, apply, and what you'll see is that the orientation now is not based off of the world, but it is aiming in the opposite, in the negative direction of this. If it was positive, basically this handle for the control here would be aiming this way. Okay, so just like that, clear it all. Okay, so let's go ahead and go to the script. Double check this. Yep. And start looking at the aim constraint. So here, let's see. Aim constraint. You can see that we're using the aim constraint, and is the values that we're using for the aim constraint there. So let's create a function for what we are going to be doing here. I'm going to define, let's call this Orient Joint. And then we're going to need the target gent, and we're going to need the we're going to need to be just call it gent. So we're going to need the target joint, and then we need the joint itself. Okay, and now that we have that, we can say mc dot aim constraint constraint typo constraint. Then let's look at how this is going to be ran. So let's highlight that, command documentation, probably open, nope. Let's look at Python, Maya, aim constraint. Sometimes if that doesn't work, sometimes I feel like it ends up being glitchy a little bit. So I just search for it that way. So we could see that we can tell it to aim constraint from one to the other, but it's going to use the settings that are in the constraint itself in the history. So we can have the weight. This is all good. The aim vector is one we're going to want to control, and the aim up. So we'll take the values from the flags that we have inside of Maya when we're looking at the example, but it's good to look at what the flags are actually called just in case. So I'll leave that open there in case we need it. We can see that we have the aim vector, which is called aim vector when we're using it in mel, but the aim vector, I guess you could use aim vector or you can use the shorthand aim. So I'm just going to use the full one, so that way if we need to come back to it later, it is a little bit easier. So we're going to say the target first is going to be target joint. And then joint aim vector is going to be equal to 1, 0, 0. And then we can do now that we have that, we need the up vector, and that is going to be equal to 0, 1, 0. I'm just trying to make this a little bit smaller so that way we can see all of the code. And I think that is all we really need. So we can test it here, and it's going to be in the create rig section. So let's say we have the Orient Joint. Let's call this Orient J and T. Then we'll create another function where we actually call this for everything. Define Orient skeleton. And then here we'll call Orient J and T, and then we give it the joints that we want. And then here we're going to say we're going to run Orient skeleton. And save this just in case. And then here in Orient Joint, what we need to do is make sure that we call the joints that we need. So for example, the hips are going to be aiming towards the lower waist. So we have hips, and that should be the J and T value. Then lower waist is for the target. Okay, so let's save this script and try running it with that one test. So it says that we have an invalid syntax. And so to test this, what I'm going to do is, let's say, pass here and comment out this section, and then let's run this to see if there's still a syntax error. So that means it is not this line. Oh, I see what it is. I put a colon here at the end. So let's remove that. Then we should be able to take this off and uncomment this line. And if I run it, there we go. We have that working fine. Create skeleton is fine. Create rig looks good. And here, if we look at it, we have the constraint. So if we look at the joint itself, I'm trying to focus in, sorry. So if we select the hips, Let's double check that we are in object mode there. We should have it as the X aiming up, but it is not. The constraint is there, so let's look at the constraint. You can see that the weight of the constraint is at 1. It's aiming towards the lower waist. And then the hips themselves, you can see that the aim vector is still not showing up. So let's double check the constraint script that we have. We can delete that. Aim constraint, target joint, JNT, aim vector, up vector. Let's create the skeleton really quick. So that we can build the constraint and look at what the settings are. So 1, we have the joints and they're going to aim towards that, so we need to select the target first, object to be constrained. Actually, you know what? Let's see if when we create the rig, what I want to see is the lower waist compared to that, so we can see that it shifted down for some reason. I think it's because, well, the aim constraint shouldn't affect. Deselect everything, create rig. And you can see that it shifts the lower waist down here, so something is not happening the way we expect it to. So let me pause the video and I'll check it to see what's going on. So what I think is going on is when we look at this, when we create the skeleton, we unlock the center joints from the X. So we unlock it, but we unlock it after we try to orient the joints. So if we take this and put it above that, then it unlocks it because we've locked everything along the x-axis, so you could see that we locked it here, and then now we're trying to align it along the x and it won't move. So that's the issue we're having right now. So let's delete that and rerun this and test to see if it is working now. Let's create skeleton, create rig, and now we have the hips lining up in the direction that we are expecting it to, and that is working great. So now we can expand on the script that we have. So we have the Orient Joint. So we've set this as a orient here, and we're telling it what joints we want to orient, and we have it here. So what we can do is set this as a variable. Oriented joint equals that, so that we orient it, and then what we can do is delete mc dot delete oriented joint. Okay, so let's try running this, and we'll create the skeleton, create rig, and now if we look in here, we shouldn't have that constraint anymore, which is perfect. That is what we want. Okay, so this is going to be how we orient everything that we have here. The only thing, like I said before, is that if it is an end joint, so if we, yes, I want to save those changes. So if it is one of these joints, which we named _end, then we want it to do at the negative. Everything else we can orient it the way we had it before. So what we can do, oops, that's not what I need open. The script editor, there we go. Okay, so Orient Joint, what we can do is set a condition. And we want to see if anything is the end joint. For the joint that's going to be constrained. So let's say we can create a list, mc.ls star underscore GNT. And then, or sorry, not GNT, but END for end. Okay. So let's print, and let's do this, save it as a variable. Print cell, just so that we can see really quick. Let's delete that, and then we create skeleton. And create rig, and we can see that we have all the end joints selected. That is perfect. So what we can do is say for selection in cell. So this is a new variable we're creating. This is looking at this variable. And then we'll set create a variable here, and we'll call it is in cell, and by default we'll equal it to 0. Okay, so for each item inside of the selection, what are we going to do? What we want to do is check to see if it equals each other. If J and P is equal to and we need to make sure that it's all capitalized, is equal to SL. Then is in cell equals is in cell plus 1. So we'll increment it by 1. And that should give us a 1 or a 0, basically a Boolean, an idea of a Boolean. Then, and we can say this is false and change it to true, so that way it is a Boolean. And then we can say if is in cell. So if it is in cell, if it turns true, what do we want to do? We want to do this, but it's going to be -1. Then we can say else we're going to do this. Okay, I'm going to save that and run it. And let's check this now. Oh, we need to clear out the scene. Create the skeleton, create the rig. Let me make sure that's clear just to make sure that there's no errors. Cool, no errors. And we can see, let's double check that it worked correctly. So if we select the hip, it is aiming the X direction in the right way. So that is awesome. So let's go back to the script. And I'm going to save this. So now what I have to do is basically create the Orient skeleton script here for each one of the joints. So now I'm going to find the next one up the chain. So it's going to go the waist. So the target joint is going to be the waist, and then this is going to be the object to be constrained. Save this, and then let's test it. Run. Now we can check this joint that is aligned correctly. This one should be aligned correctly, which it is. And then here, which we haven't worked on yet, it is not aligned correctly. Okay, so I'm gonna pause the video and just fill this out for the rest of the skeleton because it's really repetitive. And we'll see you in a moment once I finish this. I have everything set up here. There was one change that I had to do, but let me show you how it's set up. So we create the skeleton, then we create the bind here, and then we can see that all of the joints now, they will follow along the x-axis, which is what we want. See that the x-axis is lining up for all of those. The one change that I had to do was this aim joint, because I named it with reference, or REF at the end, and now we were searching for end joints, so when we look at the script that we wrote here, we created a list of all the end joints, and we didn't set that as an end joint, it was a reference joint. So if we look over here, I renamed this to be end instead of reference, and here, like I said, I changed it from reference to end on both of these, and then I also did a search and replace for anything that I was using that was already reference like this, and I switched it to the end, and then I did replace all, so that way I could fix the rest of the script. But those were that was the main change that I had to do to the way the script was working in order to get this what is it? Not UI. This script right here to work. And here you can see all the setup I did for each one of them. So it has all the joints and everything named correctly, and they're oriented now correctly. And we can see also with the end joints that they are also moving along the X as we would expect. One that you might be a little bit thinking is tricky is the palm. The palm, I just had it aimed towards the middle finger, and you can see it goes that way, and then each individual finger goes towards its own joint. So because the palm has many options to connect to, I just do it towards the middle finger because that's the most centered along everything, and then that makes it work the best with the way that we want it to work with right now. Yeah, so we have everything oriented and connected, and it looks good. So in the next video we can continue on with more rigging stuff. Let's make sure that this is safe, and we'll see you guys in the next one. Bye.